Hey everyone, so this is the first video of the series A-level exams preparations. So in this video, I'm going to do these three questions, which are some differentiation questions and also applying them to find the equations of a straight line or the normals. So let's start by question number 10. So we have this function and part A asks us to work out the derivative of the function. Okay, so we have this function e to the 2x minus the natural log of x squared plus 4. So the derivative of this is going to be, so okay, here we have an exponential function which differentiates to 2 times e to the x, because we write down the differential of the power times the entire function, minus, and here what happens is that when we have a natural log and we want to differentiate that, it's going to be a fraction line, and on the numerator we write down the derivative of inside. Here the derivative is 2x, and then on denominator we just write down whatever is inside fully. So I have separate videos covering these rules in more details. And 4 is a constant, so it just differentiates to 0, and this can be also simplified. So let's just simplify this, because here this x cancels out with this power, which is going to be 2 over x. So that's the answer of part A. Now part B says that the curve with equation y is equal to f of x has a gradient of 2 at point P. The x coordinate of P is a, so we don't know the x coordinate. Show that a times e to the 2a minus 1 is equal to 1. So for this part, even though we don't know the value of the x coordinate of P, let's just start doing the question by the usual way that we do these questions, because when they give us x value of a point and we want to find the gradient of that, we just need to use the differential of the function, so that we can just plug in the x value in that, and that's going to give us the value of the gradient at that point. So here we've differentiated this function, and here's the answer of that. And now that means that when x is equal to a, then f, or we can just say f dash a, which means that the gradient of the function at a is equal to 2, because the question has given us the gradient. Now it's just a matter of plugging numbers and just doing some algebraic manipulation. So now let's just okay, so this is a equation. So 2e to the 2a minus 2 over a is equal to 2. So yeah, this is the derivative, and then I just plugged in a, because a is our x coordinate, and that must be equal to 2, because we know that the gradient at a is 2. So now we just need to rearrange this so that we get to this point, because that's our goal. So what we can do here is, first we can start by taking away 2 from both sides and adding 2 over a to both sides, so we can just have a on the right hand side. So that's going to be 2e to the 2a minus 2 is going to be 2 over a, and here we can simply factorize. So that's going to be 2 times e to the 2a minus 1 is equal to 2 over a. And here it's just very simple, because we can now divide both sides by 2, so this 2 cancels out with this 2, so here we will just have 1. And now we can multiply both sides by a. If we do so, then we are going to get a times e to the 2a minus 1 is equal to 1. Yeah, here is 1, remember that, because we simplified the 2's. So, and that's it, so proved as required. Okay, now let's do question 11. A curve C has this equation. Part A, show that the point 0, 2 lies on C. So in this case, when we have a question like this, we need to substitute the x value into the equation, and we should be expecting to get the y value. So if we get the y value as the coordinate, then that means that that point lies on the curve. Otherwise, that doesn't. So now we are going to so when x is equal to 0, so 5 sine 3 times 0 plus 2 cos 3 times 0. So sine 0 is just 0, one of those standard values, and here cos 0 is 1. 2 times 1 is 2, which means that 0 plus 2 is equal to 2, and this is equal to the y coordinate. So that means that this point lies on C. Now let's do part B. Find an equation of the normal to the curve C at point P. So yeah, normal to the curve, we learned how to work out the normal to the curve in chapter 5 of Pure 1. One of the first things we learned in A-level maths. Now we can start doing this question by differentiating the function. So dy by dx is equal to, so we have trigonometric functions, and sine differentiates to cos, and that's going to be also, you need to consider here, which is 3x. So sine 3x differentiates to 3 times 5 cos 3x. So always make sure to consider inside as well. And then cos differentiates to minus sine, but here we have cos 3x, so that's going to be minus 3 times 2 sine 3x. Now we can simplify this, and we get 15 cos 3x minus 6 sine 3x. But we haven't done yet, because now we want to find the equation of the normal. Now for this part, it's better to just work out the gradient of this curve at this point, which is when x is equal to 0. So when x is equal to 0, then dy by dx is equal to, so we just need to work out the gradient first, and that's going to be 15 cos, again, 3 times 0 minus 6 sine 3 times 0. So here again, sine 0 is 0, and cos 0 is 1, so 15 times 1 is 15. So the gradient is 15 at x is equal to 0. However, we should notice that this is the gradient of the tangent to the curve at that point, but we want the normal. So the normal, if the gradient of the normal is a negative reciprocal of the gradient of the tangent, which means that the gradient of we can just write here, so the gradient of normal is minus 1 over 15. So now we can just use the basic equation of a straight line, which is y minus y 0 is equal to m times x minus x 0. So let's just plug in the values. Our y coordinate is 2, y minus 2 is equal to, our gradient is minus 1 over 15 times x minus 0, which is just x, because our x coordinate is 0. And yeah, we can just simplify this, which is going to be minus x over 15 plus 2, and that's it. This is the equation of the normal to the curve C at P. And finally, question 12. So we have a point P which lies on the curve with this equation. The x coordinate of the point is 1. Find an equation of the normal to the curve at the point P in this form, where a and b are constants to be found in exact form. Right, again, we can start by differentiating, but before that, let me work out the y value, the y coordinates, because they haven't given me the y coordinates, and I'm going to need that because when I want to work out the equation of the normal. So if I want to work out the y value, I can just simply plug in 1. So when x is 1, then y is equal to 2 times 3 to the power of 4 times 1, which is 2 times 81, which is 162. So this is the y coordinate of this point P, 162. Okay, now again, this question is exactly the same as the previous question with a slight difference, and that's just because we have a different function which is a different type, and the differentiation is also different. So our function is 2 times 3 to the 4x, and if you want to differentiate this, again, I have covered many examples of this type of differentiation in some of the previous videos. So what we need to do first when we have functions like this, first let's just write down 2, because 2 is a constant and that's a multiple of the function, by the way. So it's not a separate constant that's being added or subtracted. That's just a separate that's a multiple of the function. So we just write down 2 because nothing happens to that. Here is the important bit. So, and when we have functions in this form, we can start by first writing down the natural log of the base. So that's always the first thing we do, times the derivative of the power. So the derivative of 4x is 4, times the entire function, just 3 to the 4x. So it has basically 3 parts, because this, we don't need to count this one. So you can start by writing down, obviously you can memorize this in different ways, but this is also one way of memorizing that. So you can start by writing down the natural log of the base times the derivative of the power times just the entire function. Now we can just simplify this, which gives us 8 ln 3 times 3 to the 4x. So this is the derivative of the function, and now we want to work out the gradient of the point when x is 1. So we can say when x is 1, then dy dx is equal to, so we plug in the value 8 ln 3 times 3 to the power of 4 times 1, and simplifying this here we get 81, and 81 times 8, because 8 is here a multiple, so 81 times 8, which gives us 648 ln 3. So this huge number is our gradient. That's our gradient for this speed, the function. Now we just need to do one more thing, which is again working out the equation of the normal. So this is the gradient, but again the gradient of the normal is always the negative reciprocal of, because this is the gradient of the tangent, minus 1 over 648 ln 3. Yeah, so now we just need to use the basic equation of the straight line, and now we just need to plug in the values. So our y coordinate is 162, and the gradient is minus 1 over 648 ln 3 times x minus 1, and that's it. So since the question so the question has asked us to give the equation in this form, which means that we need to simplify this. Yeah, so I can add 162 to both sides, so that I get minus 1 over 648 ln 3 times x minus 1 plus 162, and that's it, because I have now written the equation in this one, y is equal to ax plus b. Okay, so that's it for this video, and if you like the video, please consider subscribing to my channel and like the video for more videos, and good luck.